talk to you about our DSD project. Our team consists of 7 members: George Mohib, Sham Zahran, Mayat Tariq, Hiba Darwish, Ali Soni, Ahmed Ali, and me, who made a friendly cleaner. The friendly cleaner is a smart cleaning robot moving along the proximity of objects like walls, furniture, and other many things, simply by searching for nearby objects, approaching and adapting itself to move it to any detected obstacle.
Hi, I'm Nawelny. I'm gonna talk to you about the components of the friendly cleaner. We have an H bridge, and we have 2 DC motors for the wheels, and 2 9-volt batteries, and a set of 6-volt batteries. And we have a breadboard with voltage regulator. And 3 active low sensors for small ranges and 1 active low sensor for long range.
We will talk about the connections of the friendly cleaner. First, we have the 4 sensors: the Altera, the H bridge, and the 2 motors connected to the same ground. The 3 IR sensors with the short range are connected to the 9-volt battery through a 5 voltage regulator. The large range sensor is connected to the 9-volt battery directly. There is an H bridge that's connected to a set of 6-volt batteries. The 4 sensors output pins is connected to the 4 Altera input GPIO pins. The control signals of the H bridge comes from the 4 Altera output GPIO pins.
I will be showing the states that we have for the car. First one, in which it's surrounded by 3 walls, to the right, in front, and to the left. Second state, where it's just detecting a left wall. Third one, detecting an obstacle to the right. Fourth one, an obstacle in front of it, directly in front of it. Fifth one, it detects an object using the long range sensor far away, and it just moves through it. Sixth one, in which it doesn't detect anything. Seventh, it detects right and in front obstacles. The 8th one, to the left and in front of it directly.
We're going to discuss 8 cases for the obstacles that meet the car. First of all, we have 8 cases. Second of all, we have 4 states: stop, right, left, and forward. First case is that the car meets obstacles from its right, from its left, from its front. When it meets all these cases, it automatically moves left. The second case is that when it meets an obstacle on its left, it moves forward. The output will be forward. Third case, when it meets an obstacle on its right, it also moves forward. The fourth case, when it meets on its front, automatically or by default, it moves left.
Continuing what Ahmed just said, in the fifth state, if the car sensor detects any of the obstacles, it approaches it. And in the sixth state, if it couldn't detect any obstacles, it keeps rotating left until the car sensor finds another obstacle and it approaches it. And in the seventh state, if there is an obstacle on the right and on the front, it moves left. And in the 8th state, if it finds an obstacle on the left and in the front, it moves right.
I'm George Mohib, and actually the robot responded perfectly to the states and worked as expected, but we faced few limitations. The first one was the material of the ground, and to avoid the robot was not walking smoothly on the ground, so we need a better tire quality, or add actually 2 more wheels for more grip. And to increase the project's mobility, we need to add a Bluetooth module to actually separate the board from the robot and control it from a distance for more mobility. Or the other solution was proposed that we added a battery to power up the board for an increased agility of the robot itself to actually be more effective in cleaning.